Our lecture today is on integration and big data. What we want to do today is not just technical skills, but also understanding how integration, big data tools, and governance come together into one pipeline. For that purpose, these are the learning outcomes. You will learn how to integrate how with relational databases using DBI, explain the role of big data tools like Arrow and Spark, implement a simple ETL pipeline using R and MySQL, applying data governance principle, recognize privacy frameworks, so document governance and privacy steps in an end-to-end analysis. By the end of this lecture, that's what you are supposed to do. When we talk about integration and big data, what do we refer to? Let's start talking about integration. Okay. Now, when we talk about integration, it's about combining data from multiple sources like a database, CSV, JSON, APIs, all these into one analysis workflow. Now, integration is a bit like a teamwork between systems. It's a bit like a teamwork between systems where you have MySQL, where you have JSON. We have different systems working together. That's what integration is about. And all must come together in R. That's the basic idea. So you have different systems, MySQL, CSV files, Parquet, and they all come together in R. Comes to pipeline, what does this mean, pipeline? Now, normally it's a connected series of steps that moves data from raw source, get it clean. So basically, it's like an assembly line if you want. It's like an assembly line where data enters raw, it passes through cleaning and transformation and analysis, and then comes out as an insight through a reporting. Now, without integration and pipelines, you would be basically copying and pasting files manually, and that's not a very good thing to do. Now, what do I mean by copy and pasting files manually without pipeline? Every time you get new data, you would have to open the files one by one, copy them, paste them into the right place, maybe reformat them, and repeat the process whenever something change. However, why is this a problem? Obviously, it's a problem because manual copy paste takes a lot of time, and it's boring as well, and increase the chance of human mistakes like pasting the wrong column, skipping rows, or using outdated files. All these. Now, with integration and pipelines, once you set up an automated workflow, that's what we refer to as a pipeline, an automated workflow. Let me just connect my um, so just give me a second with you. I'm just switching on rather. So you have an automated, excuse me, you have an automated workflow. Sorry. You have an automated workflow. And so once you set up this automated workflow that we refer to as a pipeline, the system pulls the data directly from the sources, process it, and stores it consistently without you needing to repeat these steps. So it's faster, more reliable, and reproducible. So with a pipeline, it's the main idea is that it is faster, reliable, and reproducible. All right. So you see that this make your process repeatable and reliable, as I mentioned to you. So, in simple terms, what is happening here is that we don't build an automated pipeline. We'll be stuck doing, if you don't build an automated pipeline, we will be stuck doing repetitive manual tasks that are slow and easy to mess up. All right. Now, on the other end, you also have something else that we refer to as a big big data challenges, because data, when we refer to big data, by the way, number one, we don't necessarily have a formal definition to state what a big data is. A big data, for example, can contains many columns, but at the same time, it's many rows. It can comes in volume. Volume can define a big data. You have big data can be defined through variety, through different formats. Like we have observed earlier that there are structured, there are unstructured data, semi-structured data. All these are formats. Big data can comes in different formats. Big data can normally will be big in terms of volume. When we say big in terms of volume, it means size. And when we talk about size, it can be in terms of gigabytes, it can be in terms of terabytes, it can be anything, but very big. Now, unfortunately, you don't have a precise definition for what big means. It is a bit, it just depends on your own evaluation of whether the data requires complex tools maybe to analyze. For example, there are some data that are so big that analyzing them using a simple linear regression, multiple linear regression may not work. Even logistic regression, things like that may not be appropriate. Then you might have to use more advanced tool to do that. And then when you talk about big data, it also comes in terms of velocity. When we talk about velocity speed, for example, if you look at data from the stock market in US, all right, the New York Stock Exchange. Now, data comes not in terms of minutes, not in terms of 15 minutes, not in terms, it comes not in terms of 15 minutes or 30 minutes, things like that, or in 1 hour, but it comes in every second. Maybe you have data continuously coming up. So that's a thing that we refer to as velocity and speed, and you need to be able to deal with such type of data for appropriate analyzers. So there are some challenges behind all this.
In view of doing your integration, uh, we will be using R MariaDB. Now, that is going to be the package that we are going to use, is R MariaDB. But to be able to understand the R MariaDB, first of all, you have been mainly using MySQL in this course, okay? But just for information, there is also MariaDB, which is also an open source relational database system that you could use. Just like you are using MySQL, you are using the Workbench and all these different, the MySQL server rather. You also have a MariaDB, which is another one. They usually very similar. Okay, MariaDB and MySQL are very similar database systems. Okay, so the MariaDB package, as you are seeing here, is how R connects to them. How R connects to MariaDB or MySQL. Now, just for information, there is also R MySQL, which is another package, R MySQL, which is another package that is usually used. But we are not using this one. We are using the MariaDB because it is an updated version, which is sometimes better than R MySQL, right? I'm not going to use R MySQL, but the coding, the writing, and almost everything uses DBI. They both use DBI, whether you are using R MariaDB or MySQL, or MySQL rather, sorry, or MySQL. Whether you are using R MySQL or you are using R MariaDB, you are basically writing many the similar type of codes. So it doesn't change much in terms of coding, except a few small things you have to be careful. But in this course, we are using our MariaDB, which is somehow better than our MySQL because it is one which is actively maintained and it is replacing the R MySQL, which is generally an older one. So we are going to use that package for what purpose? To be able to integrate our database in R for, of course, something I will mention to you afterward, which is to be able to track, transform, and load our data, to extract, transform, and load our data. So here we go. That's basically what we have here. So these functions that you are going to use in our MariaDB comes from DBI, right? Uh, Now, from the DBI, what is DBI? The DBI provides sort of the verbs that you need to use. For example, it gives you the get query, DB write table. All these are the same thing that you are going to use in our MariaDB and our MySQL if ever you were to use it. All right. So these are the kind of functions that you are going to write that exist in both our MySQL and our MariaDB. Now, so the key point I want to share here is to use the R MariaDB package in R. It gives you the DBI, that is the database interface for R functions to talk to MariaDB or MySQL. Bearing in mind that even if you are working with R MariaDB, it doesn't matter. You will still be able to connect to your MySQL. It doesn't matter. It is not a problem, all right? Even if you're using R MariaDB, you can still connect with MySQL. They will work well without any problem. Just for information. So I'm encouraging you to use the R MariaDB rather than the R MySQL. You can still use R MySQL if you want. The codes are generally the same. In other words, you can download this package that you are seeing here. It won't change much, okay? But because this one is mainly active, that's why I've decided to use this one. Now, here is an example of how you can connect to your database. You normally will load your library. Of course, you need to install the library. As I said to you, you can use R MySQL if you want. Okay, R MySQL if you wish. Generally the same codes that you're going to write. Just a few things are a bit different, but you will write such type of codes if you want to integrate your database in R. Such type of codes where, for example, you will write con, which is going to be a connection, which will establish a connection between your server, which is a MariaDB server. But as I said to you, even if it is MariaDB, it will still connect to your MySQL server. It's the same thing. Okay. Now it doesn't matter here. Now, you can write MariaDB, you can write MySQL, it will not matter. But normally here, I'm saying DB connect to MariaDB, which is a server, right? And then you have the DB database name that you are going to write, your district database or whatever database, campus database, you remember whatever database you work with. You put user, which is normally the root, which refers to the general administrative name that you give to your server. And then you have your password, which is in your case normally ABC123, as I explained to you to use in this course. So that's the password that you have used to set up your MySQL server, and that's the same password that you're going to use here. I repeat, it is the same password that you use to install MySQL server, and you're using the same password there. And then when you have done established your connection, you will use that object con here to be able to write your codes. For example, you will say db list table, and that will give you a list of tables that you have within your database. And what database? The database district that you have established. You don't even need to open MySQL and it will work normally. Then you can view your database in the form of a data frame. You can query your database. You can get the table, for example, select campus table, sum quantity times unit price as revenue, what we have already done before. And then you can just obtain that same table in the form of a data frame now, right? In the form of a data frame. And that is an object in R. These are objects in R, and when you have an object in R, you can manipulate that object easily. You can compute a mean, you can do visualization, you can do so many things with an object, you can do summary measures, all these kinds of things. So it makes things easy for us to transform, to analyze, and do whatever we want with that particular table. So here we are just extracting a table, just like you would have written your codes in MySQL. you are just repeating that code here under that function db get query based on the connection that you have established, and that's all you have to do. You're repeating your code that you would have done normally in MySQL. So you're just writing that code and putting it here, and then you will get the table in the form of a data frame. And then it's always good to disconnect from the it's always good to cancel the connection that you had established earlier to avoid any issue afterward if you are using R immediately afterward for something else. So that's a good practice normally to do. That's a little bit an idea of how you will use the R MariaDB example as you are seeing here. So this example just show the full cycle connecting to the database, explore table, run a SQL query, and disconnect. So that's what we have. Then I want to also discuss about the ETL pipelines. Now, when we talk about an ETL pipeline, what am I referring to? Pipelines are like a factory. What is a pipeline? If you want to understand what a pipeline is just like a fact in between inverted comma if you want, quote, I rather quote. It's like a factory which takes your raw inputs, process, and then it gives you a finished data set. That's basically what a pipeline is. It gives you the process where you are going to have your raw input going through a process, like whatever process, it could be transformation, analysis, or whatever, and then it will give you the finished data set. So you're taking this is what we refer to as a pipeline. So here we are referring to the ETL pipeline as the process where you extract data, you transform, and you load the data. What does it mean by extract? You bring the data in from whatever, from a database, from a CSV, from a JSON, from a Parquet. You transform it, and then you load the data. That is, you save the results back to your database. So you took something from your database, you made some amendment to it, and then you bring it back to the database or whatever file you save as CSV or anything like that. Okay. So why do we need the ETL? The ETL make processes consistent, repeatable, and shareable. That's the reason why we need ETL. ETL means extract, transform, and load. So the ETL pipeline makes our process consistent, repeatable, and shareable. All right. We usually use that for automated reporting pipeline. So this is a concrete. So we'll take some example here of what the ETL looks like in practice. So an example will be where you extract, that is, you get the data through a CSV file or read sales record from a MySQL table and customer details from a CSV. So you are extracting the data, you're getting the data from your CSV from MySQL. How do you do that? You are going to do that in R using that function db get query. You're going to use that using that function db get query. And then you establish your connection earlier. Obviously, I explained that to you. And then you write your code. That is going to give you your everything that you have from a table called sales. It could be the product, it could be the number of quantity, and so on and so on. And then you can also, this is loading a data from a database. This is loading a data from a CSV file, and you can also load the data from Parquet and everything as I've explained to you earlier. So what you are doing here is that you are extracting the data and you are writing either this db-get query code in R, or you're writing this read.csv in R. That's what you do to extract data. Then, when you have extracted data, you have a data, you can do some transformation. When I talk about transformation, you can either clean, prepare it, so you can do join sales with customers, fix missing values, create a new column for revenue. All these are part of what you want to do in transformation. You want to do some amendment to the data, to the original data that you have loaded, for example, and then some codes that you can write for transformation is like merge. You can write, for example, here you're creating a new column in the data by writing df revenue. Here you are excluding missing values. So here you are merging, as you are seeing. So there are different things that you can do. You can write these different codes just to transform. There are so many other things that you can do in the transformation process. I did a whole video on that for uh, data pre-processing. All these are part of a transformation process. All right. When you have transformed, then you load again. Load means you are going to write the clean data set back to the database or to a Parquet file. Generally, I'm saying Parquet file. You can also write it back to a CSV file if you wish. That's also part of the possibilities that you have. But I'm referring to Parquet file here because if you have a big data, normally it would be preferable to bring it to a Parquet file for the different reasons I already mentioned earlier in a different video earlier. So you can write it back to the Parquet file. I give you two examples here. You can write the function, use the function db write table. All these functions are available under R MariaDB or R MySQL. You can use these functions under MariaDB or R MySQL. So then here what you are doing is just writing the table back to the database. When you write table back to your database, you will get a new table called sales clean in your MySQL. So if you open the workbench, when you have done something like that, you will see the sales clean appearing in MySQL. That's just to explain what's going on. And then you have a write Parquet. That's another one that you can do, is to write your file and save it as a Parquet file. So a quick recap. So what we have done here is that we have connected to database. And when you connect to a database, you need a structure for cleaning and preparing the data. So that's where the ETL comes in. That is, you extract the data, that is, you pull data from different sources, you transform that data, that is, you clean and add the variables, and then you load the data, that is, you save the results. This is the backbone of analytics pipeline. But the issue is when the data becomes too big, what do? We need specialized tool like Arrow, for example. Now, when we talk about ETL, it works fine on modest data sets, that's fine. But with gigabytes of data, CSV becomes inefficient. You can't save file on CSV. All right. When you talk about extract, transform, and load, loading means you save the data, but you can't use save the data on CSV if you're working with a big data. All right. So that's where you need Arrow and its Parquet format. Why? Because Arrow and its Parquet format store data by column, making reading and writing much faster. All right. So this also means we can share data across R, Python, and even Spark. All right, even Spark here, even Spark. Uh, when I say that you can share data across these different software here, it means that you can do it without any conversion generally. It works very well, even Spark. Now, when we talk about Spark, speaking of Spark, what do we talk about when I refer to Spark? The first thing is that when data becomes truly massive and big, having only one machine isn't enough to deal with the big data. Only one machine is not enough to deal with the big data. That's why you need distribute Apache Spark, which is a distributed engine for huge data set. Spark spreads the workload across many machines. This concept of this Spark here that you are seeing me right here, this Spark, what it does, that it spreads the workload across many machines. And just like you have MySQL that you have been working with, and you add the possibility of using R to integrate MySQL, you add by using R MariaDB or R MySQL. Now you also have the possibility of using a package called Sparkly R. Now the Sparkly R lets R act um, as a remote control for Spark, right? That's what Sparkly R does. It enables it to, it basically lets R act as a remote control. Now, we won't be running this here, but it's important to know it because this is something that exists in the industry. All right. So it's important that you know it. I'm writing the codes here. I'm just giving you an idea of how you can connect to Spark. But for us, we are not going to focus on that, but it's just for your information. It's because this is when you are dealing with really large data set. And we are not necessarily going to do that as such here. So we are not going to spend much time, but I'm still mentioning it for you to be aware of it. So far, we've seen how to build an ETL pipeline. Okay, we've just go through that. But a pipeline isn't just a technical process, all right? It also carries responsibility. Now, that responsibility that I'm talking about is defined by what we call data governance and also data privacy frameworks. This is the responsibility that I'm referring to. Governance, what it does is that it makes sure the data is accurate, well managed, and documented. Whereas privacy ensures that uh, we respect people's information and stay within the law. That's what privacy is about, and that's what governance is about. For example, when you work with a data set from CB, as you are seeing, or Statistics Mauritius, you must identify the custodian. You must identify the custodian. You must document each processing step and anonymize, anything that could reveal personal identities. All these are important. You cannot uh, give a data set to anyone to have access to it because there are there are certain concerns where you don't want your data to be accessible to anyone, right? So there are some privacy concerns as well, sensitive information and so on. So that's the idea of what we talk about data governance and data privacy concerns, as you are seeing. I leave it to you to read this on your own. Okay, it's relatively easy. So quickly, when we refer to data governance, it's about the system of rules and processes that ensures data is accurate, consistent, secure, and used responsibly across its life cycle. And there are different principles that accompany data governance. There is a principle of accountability, quality, lineage, access control, and documentation. And I explain to you what these are here, and I give you a certain examples to illustrate that. It's quite easy to understand. You can read it on your own. And then you have a data privacy frameworks, as I explained to you. It's also about protecting individuals' personal information from unauthorized or disclosure. You don't want everyone to get access to them. So you have frameworks like GDPR. You have this is something in Europe, but then you have another one which is quite known, which is the Mauritius Data Protection Act. All right, which is our local implementation of this GDPR somehow, if you can say. So it is important that we have data privacy frameworks because then ensures your work data privacy because then ensures your work is credible, ethical, and compliant with the law. It builds trust with institutions and participants, and it prevents legal issues. You have key privacy principles. As you see here, there are there is a principle when we talk about privacy, there's a principle of lawfulness and consent, there's a principle of purpose, limitation, data minimization, pseudonymization, of a security and confidentiality. All these are what we refer to as privacy principles. All right. For example, if you talk about purpose limitation, use data only for the purpose it was collected. Energy data used for policy analysis, not for marketing. For example, you don't take that data and then you go and sell it. If the data was meant for research purposes, you're not going to take that data and go and sell it to businesses or anything like that. So there's the concept of purpose limitation. There's security and confidentiality, where you need to protect stored data from breaches, encrypt files. For example, here you encrypt files or store on secured servers. These are the different principles of data governance and privacy. So I repeat, please, you can read that on your own. It's quite easy to understand. So here we go. This is about data privacy and governance. So far, we've discussed integration, we've discussed ETL pipelines and governance frameworks. Now, let's see what that actually looks like in practice. What we'll do is we'll try to do a small project together where from raw data to reproducible output. And in the process, we'll try to apply governance, ethics, privacy, and reproducibility exactly as I've requested in your final coursework. To start with, we'll take a small scenario and we'll work on that scenario. We'll take a small example rather. That small example will test whether rainfall affects daily water usage. Let me just write this down. So we'll take the objective here. Um, we will test whether rainfall affects daily water usage. That's what we want to do. Now, this is a simple data set. It does not have personal data, it's just aggregate numbers. All right, that makes things a little bit easier. So we'll go through all the steps you need to do in your coursework, especially the last few steps rather. The first thing is that we'll create, in fact, I've already created it, but we will rather import a small data set, two small data sets rather, two small data sets. Let me show you the data set that I'm referring to. First of all, there would be a rainfall data set and a water usage data set. Let me open it. Here we go. This is our rainfall data set as you see in terms of millimeters. So here we go. It is our rainfall data set, a daily rainfall as you are seeing here. And then we will also have a water usage data set as you are seeing again here in terms of liters, all right, the number of liters used. So we are going to take these two data set as you are seeing here and we'll see whether rainfall affects daily water usage. Then the next step would be to perform an ETL process. Then we will document governance and privacy and make the whole analysis reproducible. So that's basically what we want to do here. At least this will help you a little bit in terms of how you can organize yourself with regards to your assignment. It's just a simple example, just to illustrate what you need to do. So as I said to you here, we will use two data sets, as I just mentioned. We'll name these two data sets, first of all, as rainfall.csv and water usage.csv. These are the two data sets. These will serve as our raw data sources. So that's number one. We are laying down our objective. You create here what we have to do here. The second step is now is to apply the ETL principle. So the extract, transform, and load pipeline. So we want to do that. We'll apply this ETL pipeline. So apply ETL pipeline. All right, the same that you just learned a few minutes, but with real codes now. So what are we going to do? We will start by doing the extract. Okay, let's start by doing the extract. So first of all, I will open R. Just give me a second. So we'll start by loading our library. So what are we doing here? We are starting by the extract first, right? What we are doing is that we are applying extract power process first of all by loading the library read R and reading the file and loading the file in R rather. So we'll start by loading our rain data and we'll load our water data. So we are just this step, what it is doing is that it extracts the data from CSV files into R. All right. In your coursework, this could be a MySQL query or a JSON import. The idea is the same. Okay. I repeat, in your coursework, it's not necessary that it is a CSV file. It could be from your database. That is, you apply MySQL query or a JSON import, whatever it is. You could. The idea is the same when we're talking about extract here. So what we want to do is to have our data source here. Just put that here and then I replace the whole thing backward by forward. I'm just moving a little bit fast on that because I'm assuming by now this should be quite clear. So I'm putting on my um, I'm putting here my path to my data file. So I will say read underscore CSV, which is found under this library here, read R. And then I will put in between inverted comma my path. And the name of a file, as I just mentioned to you, is rainfall.csv. This is in my folder here. Okay. And then I will do the same thing, but this time for read underscore CSV. So I will do the same thing underscore CSV, but now for the data that is called water usage dot CSV. So here we go. We can just have a brief look at the data. There are different ways of looking at that. You can just do head of rain and you can do head of water. So let's run this and try to see if it works. So there's a problem here. Just give me, oh yes, there we go. Let me read the water again. Head water. Now here we go. We've got our data, which is a water data, which is a table, as you have seen, and the table for rain is working well. So there's no problem about that. This step extract the data from CSV file into R. So the next step is to do the transform process. All right, transform. Now, when we talk about transform, what can we do here? For example, you have observed that these are two separate files. So you may wish to bring them together into a single file and do certain manipulation. For example, you join both sources. You may add a new, um, how do we say, a new column called consumption per millimeter. You may add weekday labels. You like here, you will see that you have different days. All right, you may add some weekday label. So these are kind of standard cleaning steps in your coursework that you may want to do. So to be able to do all this, let's try to do something. So we'll load our library dplyr as we have seen in previous classes, and we create a data frame which will form an inner join here. Now this inner join will be for these two data, rain and water, and you will inner join them by date. You will ensure that they are joined by the same date. So let's have a look. You have 2025 0101, and you have 2025 0101 up to 06, etc. So we have no problem joining these by dates. So we'll say by equal to date. We need to ensure that we are using the same name here. And then, so when you've done this inner join, you want also to do a mutate by creating two columns, the day of the week and the consumption per millimeter. Let me just do that quickly for you, just to illustrate. So we'll use the pipe here operator, and then we'll do mutate, creating two columns. What are these two columns that we want to create? We'll create first of all day of week, we'll give it equal, and then you will create consumption per millimeter. What is this? I will just show you in a moment. Now, day of week, what you need to do is that you need to extract the weekdays from date. So let's write weekdays from date. And then the next step is to compute the consumption per millimeter. How do you compute the consumption per millimeter? It is the water um, it is the water that you have divided by the, let me just see that, wait, you have rain in terms of millimeter here, and you have this water, where is it, liters here. So you need to take the water liters that you have, that you're consuming, out of the amount of rain that you have in terms of millimeter. Now you can just compute that. That should be fine, but the issue arises if your rain millimeter is containing a value of zero. And if it contains a value of zero, you'll be in trouble here, by the way. Don't forget that. So you may then maybe add a small value here just to ensure that there is no problem, or you can leave it as it is here. Okay. So we have just created two columns. Then we can do the add of this df, and we run that. We have to understand here when we're talking about this consumption per millimeter, it's just a ratio that we are creating where we are looking at the total water consumed divided by rainfall in millimeter for that particular day. Mathematically, its units are like liters per milliliter of rainfall. Liters consumed per milliliter of rainfall. It's just a ratio that we are computing, right? So the higher the liters, the higher this ratio, obviously the higher the number of liters for a particular amount of rainfall. So that's just something that we are creating. We're making it very simple here, though it's not necessarily something that we might be very interested in doing, but still we are doing that. And for information, remember that if the rainfall millimeter was probably zero somewhere, then you would have had to do +1. That's also very important in case there is anything like that. So you can just check quickly in your data, rainfall CSV. If there is any zero, then you might have to uh, adjust by adding some value to it to get a better ratio, right? But here there is no zero, so it makes things fine for us. We can move on. Now, here, what we have done so far is we have gone through this process of um, extract, we have done the transform. Now, what are we going to do? We have also to load the data. All right, we extract, we transform, and then we need to load the data. So, what do we do now? To load that data that we have created, we are going to use this thing, right underscore CSV, and then we'll again create the same path that we have here. I'll just copy the old thing as it is. I'm just going to change the name of the file. So right CSV. So what are we going to do, by the way, here? Let me just remind you is that here we are doing the load step, right? So we have to give it a name. Normally, you would in your data, in your real data, you won't get so easily to that step because sometimes you are missing values and everything that we mentioned in the previous video. So you might have to deal with all of these things. So let me just say cleaned water, clean water data.csv. That's what you have here. And this step loads the clean data set into a new file that we call clean water data.csv. In your coursework, you might also write it back into MySQL as well if you want. Okay, you've gone through. So let me just check what the error is. I forgot the df here. All right, so we are writing df to that file. Now I run that, it works. How do I know if it works perfectly well or not? You will see that in my folder, this is the new data file that I'm loading for you here. Here we go. So we have just gone for a simple extract load transform, extract transform load um, process. Okay. Now let us complete that particular step with an analysis. Okay. So our pipeline does not stop at the load. We are just moving on with something else where we want to do a simple analysis. Now, for that particular data where you have water in terms of liters and rainfall, if you want, you can do a simple linear regression. So a simple linear regression can be done through this function that we call LM linear model. For that, you will have your water liters depend on rainfall. So you can just do that. So in your regression model, this represents your vertical axis. This represents your horizontal axis. So we are just running a simple linear regression model. And then you can say that your data is equal to df as you have said here. All right. So you give it a name, and then we will say that we want to do summary of model just to basically get some idea about the whether the p-value is smaller than 0.05, things like that. Now just bear in mind that this is a very small data and fictitious. We might not expect much about it, but we'll see what we get here. Here we go. We run that, we get a simple linear regression where you have estimate, which is negative, implying what? It implies that as rain in terms of millimeter increases by one, as rain increases by 1 millimeter, on average, the water in terms of liters decreases by 9.3. So the water usage decreases by 9.3 liters. However, you will see that this is not significant. So you will have to pay attention to that when you are interpreting. But obviously, I'm not going to get into much details on that. I would encourage you to go and study about simple linear regression. When we talk about analysis in this coursework, I repeat,
I'm not expecting a sophisticated analysis for the time being, but at least some basic analysis that you probably have done at undergraduate level. So, but for those who have not done statistics before, you would probably want to learn what a linear regression, simple linear regression is about, or you may want to learn what is a multiple linear regression is about, things like that. This is basically what I want, what I expect from you at this stage. But if you go even beyond these two by doing more advanced analytic method, it's all fine. As I mentioned to you, uh, that will be rewarded accordingly. So we can just see the results here. You can also plot the results. I repeat, this is not a data that is normally, it's just, I've just run the data as it is, created a small fictitious data rather. So don't expect great things from that data. So you have rainfall, you have water liters on your vertical. So you put your X on the horizontal and then you put the vertical in the plot. Okay. And then you do df dollar, because that rain millimeter will not run if you did not say from where it comes from. It comes from df. Here you don't need to worry to write this down because you already said data is equal to df. That's why I didn't mention all these. So if you just run the plot here, you will see that this is the plot that you get here. I can improve that if I want by doing pch is equal to 19, for example. Just drag this to the left here. If I do pch is equal to 19, you'll see this a little bit better. You can add a title to this by doing main equal to, maybe I'll just run this down there so that we can see. So in between comma I will put daily water usage versus rainfall. You can just run that. You will see that here is your title added to this graph. Then you can change this, which is a bit messy. You can do, for example, xlab equal to, in between inverted comma, rainfall in terms of millimeter. You can do the same thing for ylab. That is, instead of having this messy df dollar rain, you can just say, sorry, water liters, you can just say water usage in terms of liters. And then let me just run that first. Here we go. You see that the things have changed here. Yeah, you'll see that this has changed as you are seeing here. Okay, so other thing that you may want to do is to change the color of this black point. If you want, you can say color equal to dark blue, for example. You have some predefined list of names like blue, etc., but you also have a color codes that you can run if you want. You need to go on Google and find them. You see that the color has changed. I don't know if you have observed it, but maybe to change a little bit further, just so that you can see the difference clearly, I will put it as red. It may not be very clear here. There we go. You'll see you can change these. And then you can also add a regression line to that plot that you have here. And to plot a regression line, you do this code abline. And then you will say abline of model that is based on the LM, draw an absolute line. It will create an absolute line, and this will give you an indication of whether there is a negative relationship, positive, etc. So we can just run that, and here we go. You will see that the relationship is negative based on that. Now you can also change the line width to greater than 1. So here we go, and you get something similar to that. So the regression line shows whether rainfall and water usage are related. It looks like there is some relationship, but inverse. It's not about the accuracy of this model that matters. It's all about showing a complete ETL plus analysis
pipeline. So I repeat, the idea here is to show you an ETL plus analysis pipeline. So that's basically what I want to do. We are not going to focus much on the interpretation of this result for the time being. Okay. Um, Now that we have done, so let me just go back here. Now that we have done the analysis, we must explain how responsible we handle the data. That's where we come to the concept of governance, ethics, and privacy. Come to the concept of ethics and governance, ethics, and privacy. Under governance, ethics, and privacy, uh, there are different things that you can do. Let me just give you a small example of what you can do in your report. When you're writing a report for your assignment, you may do something like this. All data sets are public and non-sensitive. That's already one statement that you can make. For example, you can say the rainfall in my case, data set is simulated open data. It's just something I'm writing up, okay? Now, for you, it depends. You won't necessarily need to write the same thing like me. You will need to explain what is the source of the data, things like that, whether it is open, things. Basically, you have to write some statement about the governance, uh, about the licensing and sensitivity note, rather. Here, we are talking about licensing and the governance, ethics, and privacy. There is a licensing and sensitivity note that you need to write. Okay, now under this licensing and sensitivity note, I'm just showing you here, you have these different information that you may write. You can say the water usage data set is aggregated and contains no personal information. Basically, the person reading your report needs to understand that you have gone through different ethics. You are your project has not violated any ethical principle, etc., etc. That's basically the idea. So then, for example, I can say data used solely for educational, in my case, yeah, purposes under fair use conditions. Now, you may not want to write all these same as it is. You may say that data is used only for assignment purpose or whatever you want to write. Okay, that's one thing. Apart from the licensing note and ethics, you can also write down still here something under the governance, ethics, and privacy, because it is important that person understand the data flow diagram. The data flow, you can draw a small data flow diagram. It's just a simple diagram that shows how data moved through your pipeline. Okay, just a small diagram that they explain how the data has moved through your pipeline. For example, to illustrate that, I can draw in Mermaid. Let me just explain that quickly. I will open something for you here. You will see that there is something that we call Mermaid Live Editor. You just Google Mermaid, Mermaid, just Google Mermaid, and when you Google Mermaid, you will see that there is Live Editor. You click on that, you sign up for an account. You have signed up for an account, then you can write down whatever you want to draw. For example, in my context, I want to draw a flow chart. So if I want to draw a flow chart, what I will do, I will say flow chart LR. Okay, and then I can write down all the different things that I want. For example, I will start. Well, you don't need to worry too much about that. If you want to draw it in Word, not in Word, in using Paint, it's up to you. You are not forced to do these things. But I'm just mentioning it to you here. There is this option. You will take the rainfall data, rainfall.csv, and this will move towards point B, which is node B rather, which is import. That is, you want to take that rainfall and import it. but it's not only rainfall that you want to import. You will need a node C, that is the new data, which is water, the other data, which is water usage dot CSV, and that will be moved to point B, to not point B, but to B. I already mentioned what it is up there, so there's no need for me to write it again. So I move to B. So you see that there is a flow chart coming up. Now from the import, you will see that now from B, you will see that now you create another node, and through that node here, you can see this import. When you have imported the data, you will join by date. You will join by date. You see what's going on here? You will see that now you will join by date here. Sorry, will join by date. Now, when you have joined by date, then the next step obviously is to do an analysis. I'm just showing you something that you're not compelled to do using that software, but still you may wish to use that. I think it is quite easy to apply, as you are seeing me writing right now. It's not very complicated. It's not complicated at all. So there you are going to say, okay, well, I have my rainfall data and my water usage. They go through the import, they are joined by date, then you have the analysis and output. So what I'm doing here is I'm writing the pipeline that will enable anyone to understand the process behind your analysis, how you reach that analysis. That's important. That's important in governance. Okay, that is what I referred to by the data flow diagram. Right now, risk to mitigation, risk to mitigation sorry, mitigation table. What does this mean? Still under this concept of governance, ethics, and privacy, when I'm talking about the risk and mitigation, don't forget the flow chart here, as I explained. Now, the risk and mitigation table, what I need here is that I can create a table. I'm just giving you an idea. It's up to you how you deal with it. It's just, I can create a table with three different um, columns, right? We put different rows here. So where one point I will write down the risk, one point I will write down the type and the mitigation. What does this mean? Type of risk, mitigation, and risk. The risk, the type of the risk, and the mitigation behind. So first of all, there is this issue of outliers that exist in rainfall data, and we can say misinterpretation. This is a risk, misinterpretation due to outliers in rainfall data. And this is a type of analytical risk. Analytical, because you have other types of risk. There is, for example, operational, there are legal risk, and so on. So here we are talking about an analytical risk that is related to the analysis. And the mitigation behind is that you checked for extreme rainfall values using summary statistics and box plots. So to deal with that, you have to check, we have checked, sorry, for extreme rainfall values using summary statistics and box plot. There is operational, for example, types of risk, operational. And here under the operational, for example, you can do a file overwrite or accidental deletion. What you can do with that is that you can do a backup on Google Drive. So these are the kind of things that you would mention in your report. You will say that you have checked for extreme values. There is a risk of extreme values, but you have checked for that, things like that. You will say that there is a risk of file overwrite. You have done a backup on Google Drive. Anything type of risk that you may think that exists when you are providing this, when you are doing this analysis, anything that exists as risk, you write it down and then you provide the mitigation behind, the risk. And then, for example, you have potential data licensing misunderstanding. This is a Lego type of risk. So what you do is that you said verified open data license from source website before you. So all these are issues, in other words, that you have dealt with. When somebody is going to read your report, you understand that it doesn't need to worry about that because you have checked for outliers, you have checked for license, you ensure that there is no file overwriting that may happen, things like that. And you can also, when we are talking about governance, ethics, and privacy, you may wish to link whatever you are doing to policy. All right, link. What does it mean? If it is possible, as far as possible, if you can link your analysis to your policy. For example, in our context, we're working with rainfall, environment, and so on. We can say that it relates to the SDGs. All right, if you wish. Now, that step is not compulsory as such, but still, it's very good that you mentioned that. For example, you can create a table here again. Let's suppose here I will have only two rows, two columns, sorry. One where I say the focus area, because normally in an environment you might have some policy that you want to deal with. For example, if you are in a bank, you want to ensure that you minimize wrong classification of high credit risk people, things like that. So you say that is related to your policy. It's not always SDGs. Yeah, I'm referring to SDGs because we are talking about something that is environmental. All right. So we have related national or SDG goal that you can say is related to your analysis. For example, which is water management, which is one of the focus area of the NSDG. You have a climate variability. All these are different steps of is different focus areas rather of SDGs that you can consider. Now, it's not, I repeat, it all depends what you are doing, what analysis. These are not going to be the same each time. I'm just giving you an example. If you go to the SDGs, you can refer to what SDG number this is about. For example, it is SDG, whatever it is, and then you will say that it is clean water and sanitation sanitation goal, and supports your analysis, supports basically when you're doing your analysis, supports efficient water use and conservation. So in other words, your analysis is leading somehow to these different policies. All right, that's what it is. Now, if you are working for an organization, a bank, you will say what this is about. So SDGs, I don't know what this is about, but you can check, for example, climate action. All right, this is an SDG which is related to climate action. It promotes understanding, your analysis here, ensure that it promotes understanding of weather impacts on resource management. All these are different things that happen. All right. And then the last thing that we want to do here is to ensure reproducibility of your work. So here, the last thing that you want to do in your report is to ensure reproducibility, sorry, and tooling. That's the last step that we want to focus now. When we talk about reproducibility, it means anyone can rerun your project and get exactly the same results, even on a different computer. Even months later, years later, they get the same result, right? That's what I refer by reproducibility. When I talk about toolings, it refers to the technical setup that makes this reproducibility possible. That is, you create structured folder, you have one master R script, you have an environment control that you do to ensure that the package that you are using is the same package that person will run, who will run your codes, will be using the same package. All right. So these are the kind of things that we want to do. Now we have created two we have loaded two data set, we have joined, we have done some analysis and plotted them. Now we'll reorganize our work um, in a way. First of all, we'll create a folder structure. All right. Let me show you what I mean by create a folder structure. First of all, let me create a folder in that sense. I will create a folder. First of all, I will have a master folder that we will call Rainfall Water Project. You can call it whatever you want, depending on your assignment, for example. That would be the first thing that I want to have. I will need to have a folder somewhere in your document, in whatever lecture you are doing. If your document is, for example, um, in data handling and analysis, and then you have, uh, for example, lecture 8 and then rainfall water project. That's going to be your main folder, the rainfall water project. And under rainfall water project, I will have a folder called data. All right, that's going to be a folder called data. And under data, I will have normally these two files. What are these two files? I will have rainfall.csv and I will have water usage.csv. These are the two things that I will have under that folder data. Then apart from data, I will have, for example, another folder that will give me the outputs. All right, I will have another folder that give me the outputs. Now that's going to be another folder that gives me the output. But for that, I don't need to create it right now myself. I'm just mentioning what you will have. Some of them you won't need to create it because we will create it in our master R script. All right, in our there's going to be a master R script that we are going to use where we will create that folder. But anyway, I'm mentioning it. Then you will have another folder that is going to be an R folder, which will in fact contain your R codes. All right. When I say R codes, there are different ways that you can work in your folder. You might have different R scripts that you have saved, and for example, you might have an R script which is to load your data. You might have an R.R, you might have another R script to clean your data. You might have another R script to analyze your data. We will refer to it as analysis. You might have another R script to plot your data, for example, right? So you might have several R scripts. Now, the problem is that it's not very nice, for example, if you're doing an assignment and expect me to go through each of these one by one and run each of these one by one. It would be preferable to have a master script that maybe I will call it as all.r. All right, all.r. So that's one of the convention that normally you will use. In that same all.r, you will be able to, in that script of all.r, you will source this load data.r, you will source this clean data.r, and you will source this analysis data.r. That is, you will probably run a code in your R script, in your all R, you will run a code for each of these. All right, source, and then you will put down, sorry, you will put down your path here where your folder is located. All right, and then you will put backward to forward, excuse me, you will put something like this. Okay, here we go. That would be something that you will have in that all R script. In other words, it will go and locate that load data.r and run it. And then you will do the same thing in that all R, which is for clean R. So you will have clean R here and it will run it. So you will have 1, 2, 3, 4 lines of code, for example, in all.r that refers to these four different R files. All right. Now, the thing is, you could also avoid doing that. You could do all of these rather than having separate files. You could write everything in only the master R script. It's up to you. You normally organize yourself as you wish. Now, but if ever you have several files like that, it's good that you state the order in which the person needs to run these different scripts. For example, you might use some convention like 00 all to refer to the first script that needs to be run, and this one is 01 underscore, this one is 02, for example, when you are going to clean, and then when you're going to analyze, that becomes 03, and of course the plot becomes 04, in this order. So you can use this convention. So what we will do is that in this particular example that I'm taking here, I will not use separate files for loading, cleaning, analyzing and plotting. I will just consider only one single file, which is double note double o all dot r. That would be my master script that I'm going to use, and that runs everything. That runs everything. You could use it, as I said to you, to source different files. So instead of using source, you could write your all codes in that particular file itself. But as I said in this example that I'm going to take, I will write everything in the single file. So that's the kind of thing that you want to do in your R folder. Apart from the R folder, we have other things that we would want to do. Okay, there are other things that you want to include in that folder. Rather, what are the different things that you would include in the folder apart from this? How apart from this R folder, you will have first of all 00 all, but apart from that you will have another folder that will be that would be obtain, that we will call our environment log. What is this our environment log? This will be created later. I will explain to you later what this is about. This is where it ensures that you have your reproducibility. You have the reproducibility of the same library again and again, because you know libraries get updated every time. So if you are running that code today, and after 5 months you come and run that same code, you might find yourself into trouble if there has been some update and your codes may not work anymore. So when you are doing when you are doing this environment setup is locked on your current libraries that you are using, anyone can run the same code after 3 months, 5 months, and you get the same result. But I'm not going to get into the details right now. I'll get into that details later in a moment. And then you can also have a README file that will normally give instructions on how to uh, how um, to go about doing your analysis. So basically, that's the kind of thing that we want to have as structure. I will get into that README afterward. Don't worry. So, in that respect, what I will do, I will start by doing it. I've already started partly here. So, you have the lecture 8. You have, for example, this is my whole path for me, rainfall water project. And then I have my data that has already been included. But as I mentioned to you, that's only part of it. Let me just open that again. So, I've done that already. As you are seeing, under data folder, I have my two data sets, but then I need to create another folder. I'm not going to create the output as I mentioned to you, because that will be created in the R script here that I'm going to do. So I create another folder. I will call it R. And in that R folder, I will open it. And then I will write down, there are different ways of doing it. You could open a R file. You could open a R. So here we go. Let me just do that. A blank R script like that. And then you are going to write all your codes here. And then you're going to save it as, of course, the name. You are going to go and save it as the name, Rainfall Project R. And then you're going to call it 00 all dot all 00 all underscore all, and that would be saved as a R file. That's one way of doing it. Oh, by the way, just for information, you could also do it differently. You create a new notepad file, you right click, you say new, and then you create text document, but in that text document you are going to rename it. All right, how do you rename it? You remove the whole thing including the .txt. You see, you remove everything including the .txt. When you remove everything including the .txt, let me just increase that a little bit so that you can see better. So when you remove everything, including the .txt, you are going to replace it by the name that you want. So 0000 underscore all, and then you put .r. Don't forget to put the .r. I repeat, remove a .txt so that this is not saved as a text file, but is saved as an R, as a R script rather. You remove a .txt and then you put .r and you just do enter, and then it will ask you if you want to change the extension. You just say yes. When change the extension, you won't see much appearing here, but you know that this file now, even if you are opening it as even if you are opening it as a notepad, it's in fact saved as an R extension file. And now you will write all your codes. So I'll just take a pause on that video and I will paste all the code immediately so that we don't take too long, because we've already done that, but I'm going to do it a little bit differently here so that I'll stick to the same thing that I've been doing earlier, but a bit faster, okay, and a bit cleaner and neater. So here we go. I'm not going to repeat myself because we've already been going through all these different libraries and so on. But look at that. You see that it is loading library read R, deploy R, and so on. At a particular point in time in the future, that might be updated. So you will understand the importance of run or env lock later. Okay. Now you will see that I've created my folder. I've set my working directory. That's another way of working that maybe I did not explain to you earlier. So you can set your working directory instead of writing the old path right in the read underscore .csv. You can create your working directory. You can create your working directory. And my work directory is all these, including rainwater project, as I mentioned. So in other words, I'm referring to that particular folder, rainwater project. That's all I need. So when I've done this set working directory, you would see that I did not include data as a folder here. I've just taken the main folder, which is rainwater project. I did not put the data here. You will see later why I'm doing that, okay? But for the time being, I'm just putting the main folder, and then I will say read underscore CSV. You will see that I put data slash, and then I put the name of a file. So now when I'm reading the data, when I'm going to load the data, that's where I don't look at rainwater project, but I go one step ahead and I get into the data folder. So how do I get to do that? I have my master file folder here. Then under my master folder, I got another subfolder called data. And under the data subfolder, I have my file called rain.csv, as you are seeing here. So that's how I do that. So I put rainwater project here. I don't put the slash anything. I just leave it as it is. And then I put data slash, which means that when it is doing read underscore .csv data rainfall, it goes and identify that path that I've given, and it will fetch the data folder from that master folder. What master folder? From that rainfall water project folder. So when I do that, this data slash, it means data slash is a folder that exists somewhere, and it exists under that master folder rainfall water project, which is located on that old path that I'm highlighting right in front of you. And the same thing applies for water. I can run that if you want, and the library as well. I'm just going to execute that, but before executing that, I need to open it in R, right? So to be able to open it in R, what I've done here, I've saved that as .r. I can close the notepad completely. I can now open R. And when I open R, I then click on File. When I've clicked on File, I click on Open Script, File, Open Script. And when I click on open script, I just need to locate the R master file where it is located. I think you would recall that I've saved it under Rainfall Water Project and R folder. You recall that? So you see that it is already .r, which means that it can open the R file without any problem, and it is an R script, so I can tile horizontally, and then I can run these few codes just to see if it is working, and that's what I do. And it seems to me that it is working from what I see. You can just select rain, and you will see that it's working very well. So what is the advantage of using that master folder that you are seeing here? Because later I will create a directory which is called output, as I mentioned to you, for example here. And excuse me, I'm going to create an output under that master folder, Rainfall Water Project. That's why I did not right from the start already put data here, because that's not the only thing that I'm going to do in that Rainfall Water Project. I'm not gonna only do a loading of data, but I'm going also to create outputs. That's why I'll just use the master folder, as you are seeing. Then I've done all these different things that I'm not going to go into again. I've done some transformation, some analysis, as we have already done, maybe a little bit neater here. And then here we go. We run all these. Okay, we've got all our results as usual, but then we come to that step where we are going to save our file, our results. There are different results that we're going to save. And to save these different results, I need to create a directory. Look at that for a moment. There is no directory apart from data and R. These are the only two directories. You will see that these are the only two directories that you have. And these two directories that you have, you will need to create a new directory. What is this new directory that you're going to create? You create it through dir.create, and you say what folder you want to create. So in other words, when you are going to run that code here, it means that there will be a new folder that will be created under what? It will be created under that set working directory that is under this excuse me, it will be created under this Rainfall Water Project here. All right, that is under what you have decided to set as working directory. So this output file that we are discussing right now, this outputs folder, will be created under this Rainfall Water Project. All right, that's what is going to happen. So let me just create that. Let me run that. So you are getting it why now I did not load the data set working directory through that folder, but I set it through the master project so that I can do all these different things that I'm doing right now. So I'll just execute that for the time being, and then we will see that there is the output file that is appearing, folder, sorry. Now, under the output folder, you will see that I can capture the summary results that I've got here. You see these summary results that I've got? I can capture these results and send it to the output file as a text file, for example. To be able to do it as a text file, that's where I'm going to run that code, as you are seeing, capture.output, which is a function that will use summary model. That is what we've just done here. It takes that result and it saves it as a file under outputs, as you see here, because if I leave it as file like that, you know what's going to happen. That is going to save it under that folder, but I don't want it to be saved under the Rainfall Water Project, but I want it to be saved under output. That's why I need to do uh, outputs slash, and output slash means it is under Rainfall Water Project output, and then model summary, I call it a name. I say it, for example, it is model summary, and then I give it .txt. It's because I want to be saved as a text file. Then you can take that text file and copy and paste it in a Word or wherever you want, but I'm saving it as a text file. So let's run that and see what it is. First of all, just bear in mind that there is nothing under output in the output folder. But when I'm going to run that line of code here, you will see that now an output folder appears, and you can open the model summary as you are seeing here. You can open the model summary, and that works well. You get all the results that you can copy and paste in R if you want. Okay, so that's one thing. And then you can also save your file or picture file. What picture file? You have done a plot earlier of rainfall against water liter, or water liters against rainfall rather, and that's what I'm doing here. I'm not going to repeat it again, but I'm just going to save it as a picture file, which is through png instead of JPEG. I could also do JPEG if you want, but I'm doing it as PNG, and define the aspect ratio through the width and the height. So, for example, that is going to be a sort of rectangle that is going to appear as a file, as a picture file, rather than a square. If this was 600, 600, your output will be saved as a sort of square. But because I put 800, 600, that's an aspect ratio that gives us something which is a bit similar to a picture, which is similar to a rectangular picture, for example. But and that's one thing. So let me just run that output rainfall.png, and then you will see that when I'm doing that, I'm creating the picture file, and I will run that plot, which will be loaded in that picture file. I will run my regression line as you are seeing here, that will be run on that plot. But then I will need to do device off so that this plot appears. So let me run these together. Device off so that the plot appears as you see here, rainfall water PNG, which was not there earlier. So I got something like this. I got something like that. So you will see that the width is greater than the height. This is supposed to be 8 to 6, for example. Okay, 4 to 3 if you want. That's what I get as result. And this result has been saved in my output folder as you are seeing. Don't forget to put the device off, otherwise it won't work. All right, then you will see that I've written a small message here to say that pipeline is complete. So this will appear in your console as you are seeing here, pipeline is complete. So here you will see that you have done through the extract load, through the extract, load, and transform and analyze as well. All these have been we have gone through. So we've got our R master file, script saved here, as you're seeing here, save here. You will see that you have also your output saved here, your outputs, and you have your data already saved here. That's uh, the kind of thing that you have. Now, you may, rather than going through all these codes one by one, let me explain to you where the reproducibility of your result comes in. This is your R master file. We are going to close everything. Let's close everything for a moment. Okay? And then I will open R again. First of all, I will delete the output, or delete the output folder, because this has been created through my file here. You like it or not, these two folders needs to be there. So I need the data in the project file. I need the master R scripts and all the different R scripts that accompany that master R script, if you want. And then I will need R open, like that. So R is open. I will just create a new script just to make things a little bit easier. I will go in my in my rainfall water project. I have only these two folders. I've deleted the output folder. Just remember that. I will come in that R folder where I have my master script. I'll just right click and copy as path. Right click that file and copy as path. I go in R, I'll save that path here, and then I will do source, open bracket, close bracket. I change the backward to forward as usual. That's something that I'm sure you got used to by now. And that's the only line of code that I need to run to be able to reproduce exactly the same result that I have been getting earlier. In a matter of click, I will just go in this place here. As you are seeing, there's only one line of code. I just execute that and just look at what's going to happen here in the folder. You see, it automatically opens create the folder with only a single line of code. It automatically creates the folder with all the summary statistics that we have obtained earlier and the clean data set that we have obtained as you have written in your R script. That's the core of reproducibility that we have just done. A single script that will always work end to end. So, in other words, when you are going to provide me with when you're going to give me your assignment, you will need to ensure that your work is reproducible. That is, by just running a single line of code like that on my computer, I'm able to obtain the full result without any problem. But bear in mind something. Even though you have done all these steps that I've just explained here, there is another important aspect here. So we are talking about reproducibility, as you see here, and that reproducibility, the first step, step one, was to create your folder structure. Then, in the second step, what we have done, we have written step two, we have written the master script and we named it whatever folder we want, 00.all.r. Okay, .all.r. We've done that, and that's just what we have been doing anyway. I've been writing that, and then we in step three now, as you have seen here, you can rewrite that source R code, just source it and run it, but it may even not run because you may not have uh, created the right environment for that person who got your analysis to have the same results. To ensure reproducibility, you need to do an environment control. You need to do an environment control with something that we call renv. Okay, with renv. So if someone has a different package version, your code might break later, and we are going to fix that through the renv. Okay, what does this renv do? It freezes somehow in between. uh, it code like as if it freezes your R environment. That is, it ensures that when somebody is going to run that again, he will obtain exactly the same result like yours because he's going to use exactly the same package, not an updated one, not a package that is updated after 3 years and then you run it and then it doesn't work, but the same package that you are running now. Now you have your folders as you are seeing here. This is your working project. You need to set that working directory as you are seeing here, right? You need to set that working directory into your R to be able to apply this renv. So we are going to just do something that we have already been doing earlier. So we'll bring that into quote with comma, and then we control H backward to forward. Excuse me, backward to forward, replace everything. So we change our working directory. You will see that there is no file name in work directory. There is only the folder. And then I'm going to say set wd. That is, in other words, setting R to that particular folder here. All right. So in everything that is going to happen will be worked within that folder. So I just run that. That's done. The first step is to install the README package. All right. If you don't have it, you will need to do install the packages maybe, and then in between there you will do ren v, which is your environment that you're going to install on your local file. But for me, I'm not going to run that. Now, when you are going to run that, you will need to use cloud or maybe other servers if you want, but you can use cloud. But for me, I'm not going to run that because I've already got it installed on my laptop. So I'll just skip that step. But you might have to do that if it's the first time you're doing it. Then the second step is to initialize the RENV inside your project. Right now, you see that this folder contains only these three folders. This rainfall water project file folder contains only these three folders: data, output, and R. So what are we going to do now? We are going to initialize this for the RENV, right? This set up the project specific environment. When you're going to create that, you will see that there are going to be three things that are going to appear. There will be one, the RNV folder, the RNV folder. There will be something that we call an R profile, and there will be something that I mentioned to you already earlier, which is the RNV lock. All right. So these are the three things that we are going to run. Okay, we are going to have rather. So we'll do init, and then we do enter. Could not find function. Sorry, I forgot to install. I forgot to put library init here. Sorry, not library init, excuse me, library renv. I run that library renv. I do init here, and then when I do init, I will get something, and here we go. We get information about the different packages, etc., etc. You can just go through it. You will see that there is readr, there is renv already installed, there is rlang, tibble. All these are packages that I've been working on before, and these have been loaded here. Now, you will see also, I think there is a dplyr that is here. These are the two packages, by the way, that we have been using in our project here, the readr. You will see that these are already installed here. And there are other packages. Now, let's try to open the folder. You see that there is the RENV, which is a private project library, and it contains metadata about your rainfall water project as well. Well, not rainfall water project, but about all the libraries that you're using, rather. And then you have the RENV lock, which record the package version. If you right click and open that notepad, you will see clearly the different information. Here we go. These are different information that are contained that you get here. I'm not going to get into that. There is no need, but you will see that there are different information pertaining to your R environment file, and it gives you the package version. It gives you the R version that you have installed. It gives you so many of information that you can go through it. It's not necessary. You saw the dplyr anyway, and so on. Now, then there is this .r profile that normally what it does here is that it activates the RENV automatically in this project. Whenever you are giving that R profile, next time when you are running your R code within that particular folder, it automatically take this R environment with its specific libraries and run it. So in other words, if after 5 years you come and you run a project within that particular working directory, you will not have any problem. It will work automatically with the old package version that has been installed through that particular folder here. All right. So, but now you need to check whether your folders contain. You can go there and click on library, Windows, you carry on. and then you just check if your package is here. You will see that there is renv. This is not what matters here, but more importantly, what matters is that we need to have the read r and the deploy r package. So you see that there are the deploy r, look at that, and you have a read r package. These two packages are already there in this environment, so we do not need to worry too much about it. So, in other words, there is no need for us to load to install the library. Otherwise, you know what you would have had to do? You would have had to do install the packages and then you put the library there that you want to install. But here, given that it's already installed, you don't need to do all this. Okay, so that's one thing. And then, nevertheless, what is good to do is that um, once the required package are already installed and the pipeline is running correctly, as you saw earlier in the master R file, you need to freeze that particular version. You see here, for example, you are using version 2.1.5 for read R, and for what is it, deployer is 1.1.4. You need to freeze that version so that anyone that is going to use that later will be able to use the same version. And if there are updated functions within deployer, the your codes will not break. Okay, if you have to run this code. So I remind you that you are doing reproducibility here, and you need to ensure that everything stays as it is every time. So what are we going to do? We are going to freeze that version, and to freeze that version we need to type snapshot. Type snapshot. What is happening when you're typing snapshot? You are going to run that. It says activate the project and use the project library. Do not activate. So obviously you will say one because you want to activate the project, and you do enter. When it does that, what it is doing here is that this write the exact versions of all packages into your renv lock. I'm not going to get into the details here. You can open it and see it will write the exact version that has to be loaded. And anytime now, you can run your analysis from scratch. You can run your analysis from here. You will say source, for example, and then you will do, where is it? You will do source, and then you will need to get that path here, copy as path. Source here, copy as path, and you control H backward to forward as usual, and you replace all. And then what you just need to do is you have sourced these file, and then you can run it. By the way, let me delete that. um, let me delete Let me delete that output folder just to see if it works. Normally it will work without any problem because anyway it's on my own laptop. So but we're gonna run the source of file. When you are doing source of file, it goes into that particular master script that we have created earlier, and it run it from scratch using that particular environment that we have saved here. So it loads the correct uh, environment. You can just run this and you will see that your output is created again. Now, just for your information, um, it's good that you have done all these so that me, when I'm going to get your assignment, for example, when I'm going to get your assignment, to be able to use all these uh, packages that are installed in renv, I will first of all need to have this library renv. That's one thing. I will need to set my working directory again. My working directory will not necessarily be the same as your working directory. It will change, but at least I will need that a folder somewhere. It will depend on the different assignments, and then I will need to do something like restore here. Restore. I will need to run that code. You don't need to do that, you, because you are creating it. But me, I will need to run that restore to be able to get the same packages that you are running on your laptop. You see, that's very important for reproducibility of result. If you don't do that, and let's suppose you are running a deploy version that is old, or a I don't know, some other versions of a package that is old, I have trouble to reproduce the same result. So that's why it is important that you ensure that everything is reproducible by doing all these different things that I'm mentioning, by setting your environment etc. So the R environment gives each project its own set of packages. Even if you've used dplyr before, this project needs to uh, either copy or link it to into its own mini library, as you have seen. Now the final step is to create a README file. Okay, let's say step 4 out of all this work that we have done is to create a README file. All right, how do we create this README file and what is it about? So first of all, what we want to do, you want to document what the project is about. You want to explain how to run it. You want yourself or other people to reproduce the results easily. That's why you create a README file. And this README enables anyone to have an overall picture of what they need to do. So it's short explanation of your project. To be able to do that, there are different ways. You could just right click and click new and click text document. When you click on new text document, that you create a new notepad, you will give it a name. You can call it readme.text. That's all. And then you start putting all your instruction inside of that readme.text. You can put all your instructions inside. Nevertheless, there is another option is that instead of writing it as a plain text file, you use something that we call a markdown. Instead of the extension .txt, I remove that and I replace it by extension MD. MD means a markdown. What is this markdown going to do? It enables your plain text file to be editable, to not editable, to be readable in a very nice format. That is, when you are reading it, you will see, for example, there is a title that is in bold, that is big, then you have bullet points, all these things. That's the advantage of the MD, which is not the case in a plain text file. So I can just put readme.md and then I say, yes, change the extension. But I repeat, if you don't want to do that, it's okay, it's up to you. But normally it's good to do that. I will show you why it's good to do that in a moment. What's the advantage of this? So just to make things a little bit faster, I've already, let me just open that file, it's blank. I already have a README file somewhere. Let me just open that README file and copy paste that here. Just give me a second with you. I already created a README just so that we don't take too long. So I will put it here and I will save that README file as you are seeing. So you will see that when I'm writing the README file, I'm not writing things like that, rainfall, and then I keep on writing. But you will see that I have some symbols that I'm using from here and there. These symbols, they help me to create a file that when you have to read it, it looks nice. What do I mean by that? For example, you will see that there is this asterisk that I'm using, this hashtag, sorry, not asterisk, this hashtag that I'm using, which represent a heading. And this dot here, for example, this hyphen here represent a bullet point. So what are the purpose of doing that is that when you are putting title, when you are putting bullet point, it makes things easier for someone to read what's going on in the file. For example, here you have a subheader, you have a header, you have a subheader that is used, a smaller font will be used for that, etc., etc. You have different things that you can do. Now, quickly, before I show you the use of having all these different uh, notations here, quickly in the README file, I will write something like that. I will give the title, which is Rainfall and Water Usage Project. You will say what the project is about. You will say that it contains two files, that etc. You can write it in your way, whatever you want, as long as it is descriptive, it is clear and self-explanatory, so that anyone that reads it, so that when I read it, I get a clear idea of what has to be done. That is, you're giving me instructions. So, for example, how to run the analysis. You tell me open ROR Studio, set the working directory to this folder, run this code, whatever it is, and then you say install packages, run env if you have to install it, restore. This means that this is going to be done at my
place. You don't need to do that you, because you are creating it as I mentioned to you. Then you are going to say run this source R code, which is going to be only a single line that I run in R, and I get the full result that you are doing. So in other words, I don't need to copy and paste your code in R or whatever. I just need to run that small line of code as I've shown you earlier, and I get my full result. When I say R, you don't need to put R. It will normally be your full, how do we say, your full, excuse me, it will be your full path. Okay, see, whatever it is. Me, I've just put R here, but it's not R, it's a full path that you're going to do. And then you put some note: this project uses renv to freeze whatever it is you want to write. So you got something like that. You know that there will be some bullet points, etc. Now when you save that file, normally each time you're going to open it in text file, each time you're going to open it, for example here I come and open it, you will see there is not much happening. Sorry, let me just see that for a moment. So there is something there that is not necessary. This I don't need, this I don't need, this I don't need. I don't know why I got that, sorry. So when I'm doing that, just give me a second with you. I say that, I close it. Normally it will create a markup file. Now that markup file that you are seeing, just give me a second. Yes, that markup file, that each time you're going to open it, you won't see much appearing. It's just a plain text file, you see. There's not much appearing. But me, for example, if you are using our studio, normally that markdown would work well. If you are using a plain notepad, that would plain note file, notepad file, that would not show much. But let me show you, for example, one use of having this markdown. You, I don't expect you to know that, but still I'm just mentioning it to you. Using this markdown with those texts, you can put it in GitHub for those who can use GitHub. You are not compelled to do that, please. I remind you, you are not compelled to do that. For you, those who want to use GitHub, you can use GitHub and create a folder and put your work there, for example, for your own purpose. And then when you are reading a MD file, look at what's going to happen. You are going to write your code just like what I have here, what I've got in this text file here. I'm just going to copy and paste that code, or just grab it and uh, put it in the GitHub file here. And then what I do is that I click preview. Now, when I click preview, look at what it looks like. It looks like a very clean, nice, readable format. So normally when you're saving your file, it's good that you put the .md. So that me, if I have to put everything in GitHub to read, for example, and run, I can do that. Or if I want to use our studio, I can do that. There are also other ways I can read your MD file. There are different editors that I can use to read your MD file, and this is more readable compared to having a simple plain text file. But you are not compelled to do that. Just for your information, I mean, the use of the MD. For you, you could just do a plain .txt. As long as it is clear, then you put a plain .txt. That should be fine for me. But I'm still showing it to you. If you do a plain .txt, that should be fine. Then there is no need for you to put all these different markups. But still, as far as possible, if you are able to do it, that would be very good. Okay, so here we go. That's the end of this class, of this module. We've completed everything that we had to do. We Now I hope that you have sufficient materials to help you complete your assignment. Thank you for your attention. I wish you all the best. Take care.